Believe me, there are lots of other collections in the standard library besides just vector and map. Take, for example, list. It implements a linked list. Now, vector keeps its elements in a continuous block of memory. When you delete an item from a vector, it copies everything that was after back so that they all still end up continuous in memory. A linked list, they're not continuous in memory. Each element of the list is in its own little piece of memory and has within it a pointer. List happens to be a doubly linked list, so it has two pointers, one to the previous element in the list and one to the next element in the list. So it's super fast to add new elements, but it's slow to traverse the whole list. Now, I want to point out something really important. You traverse the whole list of a linked list exactly the same way you traverse a whole vector. You say, give me an iterator that points to the beginning, keep going as long as we're not at the end, and increment the iterator with the plus plus. An iterator over a linked list knows that in order to increment, it has to traverse the link. An iterator over a vector knows that in order to increment, it just has to move on by the size of the element to the next piece of memory where the next element will be waiting. But those are implementation details. The cool thing about the standard library is they all have begin, they all have end, they all have iterators that have a plus plus. They all have a size and a clear and an erase and other methods that I haven't been able to demo to you yet. They're consistent from container to container. That means when you change your mind about what container to use, you really change a very small amount of code, especially if you've been using auto to declare your iterators, because then it's still auto even though it's an entirely different iterator when it's an entirely different collection. So list is faster if you're adding and deleting and reorganizing, slower when you're traversing. You look at your application. Maybe you add, delete, reorganize all day long, and then at the end of the day you run through the list once to do a report. You'd probably choose to use list. On the other hand, if you sort of set your vector up and then are constantly going through it and you hardly ever change it, well, then I would use vector. If they're small, it doesn't matter. You can choose whichever one you want. Only once you have a performance problem should you try to solve performance problems. But knowing the various performance characteristics, and they're well documented all over the internet, of the different standard collections lets you make that informed choice. There's more to life than performance. You might actually want different behavior in terms of how you access the elements. So, we used maps so we could look things up by a key value. Queue and double-ended queue support that push and pop. It's not a stack, which is last in, first out. It's a queue. So whoever goes in first comes out first. You push them in at one end and pop them out at the other. And there's a subset called priority queue, which lets you assign a priority to each element so that if you push something in, it might leap up to the head of the queue because it has a higher priority than the items ahead of it. Then there's set. Unlike a vector, set doesn't need to reorganize itself whenever you add or remove an element, and it allows you to keep iterators going even while you're messing with the contents, which you can't do with a vector. It also has some operations available like intersecting two sets to figure out what things are in both sets or what things are in one but not the other. If you're doing those kinds of mathematical operations, set is a great abstraction for that. Multimap, just like map, except you can have two things at 1, 2, 3 within your map. And there's more as well. These are fully documented. They are literally standardized. There's a committee that chose them all, and it's easy to find out the entire contents. I recommend that you start with the simplest thing that could work, which is probably going to be vector or map. And if and when you become concerned about performance issues, go to the documentation and see what other collections are available to you. The great thing is, because of the way that it was all designed in a standard manner, much of your code will be completely unchanged even when you change your collection type.